We're looking at systems of linear equations here in 7.1. In our last video, what we said was we could graph and find where do the two lines hit each other. That's the point that's the solution to the system. Well, graphing has its difficulties. If you got a nice tool, it's easy, but if not, it can be challenging. So let's learn how to do it mathematically. There's two approaches. You've probably seen this somewhere in your past. It's certainly an Algebra 1 topic. So we can solve a system by substitution. Substitution is this: if both of these lines exist in the same universe, so if I solve one of them, so let's solve this for x, for y. Y is x minus 5. If that's what y is in this first line, that's what y must always be in this entire universe, this entire graph. So if y is x minus 5, why can't I replace y in this system and sub it in? So I'm going to replace y here with x minus 5. So remember, you sub something in. So if this is y, I'm replacing it with x minus 5. So I put it in parentheses, I distribute, and when I solve this, I find the value for x to be 8. Now that's only one part. Let's find his partner. I can put 8 into either of the equations, and if I do, I find that y equals 3. So if I make this substitution and I can come up with a value, then it means that this is where they intersect each other. If y equals x minus 5 in the other, and I plug it in, I find the point where the two lines are actually intersecting. So 8, 3. So if you check this, what you find is 8, 3 is on both of the lines, which we learned that means that it is a solution to the system. So we're going to solve this by substitution, and it doesn't always have to be y. You can solve it either way. And if you notice, this is already set up. I know what x is. Well, if this is x, let's put it into the second equation. So I've got 4 equals 3. So y plus 3 all represents x, so it's all going in parentheses. Now let's solve it and see what we get. 3y plus 9 minus 2y. Okay, so I get y is negative 5. Now I need the whole point. I can use either equation. So x is equal to negative 5 plus 3. X is negative 2. So because I plugged this into the other equation and I was able to find a value, they must hit each other. There is some point where this line goes into this line and makes it true. That's what we're doing. We're taking the first line, we're putting it into the second one, and seeing if it makes it true. Well, if it does, and we found that it does, then this is the point where both lines are true at the same time. That's the point where they intersect. Now I'm going to mess this next one up. I call this elimination. Like all books, we'll call it different things. But so this book, OpenStax, is referring to this as the addition method. I'm going to keep forgetting. I call this elimination. If I write your test, I would call it elimination. But what we're going to do here, elimination is just a big addition problem. What we're going to do is we're just going to add these two lines up and see what happens. Now, what we want, though, is we want something to be the direct opposite of each other. So if you look at this, if I treated this like a middle school addition problem, if I add these x's up, the x's are going to go. So we're going to try to combine these equations and see if there's a point where they hit each other, where they're both true at the same time. So let's just do it and we'll see what we get here. We get 3y. So if I add this up, the x's are going to go. 2y plus another y is 3y. If I add this, I get 2. So solving for y, we get 2/3. So if I just try to combine these equations, what I find is that y equals 2/3. Plug 2/3 back into the other equation. I get x is negative 7/3. At this point right here, what I have is a place where they intersect. I have just combined them, and I found a y that's true for both of them. Now that y that's true for both of them, I plug it back in, and there's obviously an x that's true for both of them as well. And by using a big addition problem, I've combined them to find if there's a point that makes them both true. Okay, so let's try again the addition method here. Now, if you notice here, the problem is if I just add these up, nothing is going to disappear. So what we can do is we can multiply through to either equation. If I multiply through an equation, I haven't changed it. As long as I've multiplied all the way through, it's the same equation. And so I haven't broken anything. So why not try running a -3 through this bottom equation? If I do that, I've then created something that would allow me to add and make the x's disappear. So I'm going to run a -3 through there, and now I've got these two equations. I should do it up here. Well, hold on, maybe they already did it. Yeah, they did. So 3x plus 5y. Now they've run a -3 through this bottom equation. You do it everywhere on the left and the right, and you get this. Okay, now we're set up for that elimination or that addition method. I'm going to treat this like a big addition problem. The x's would go. I've got 11y equals -44. Y is -4. So I have combined these equations, and I've found that there's a point where y is -4. If I solve that for x, I get x's. You can plug it into either equation, and I get the point 3, -4. So this is where these two lines intersect, at the point 3, -4. So we could try this again here. Now you can choose any method. What we're going to see is sometimes you have to multiply both equations by something in order to get it to create those opposites. But on this one, it doesn't have to be the x. We're going to make the 7, run a 7 through here, and then I'll have -7y and +7y. So here's what I've got. Okay. So I have opposites now, so the y's will drop out. So let's make this a big addition problem. Let's see. Hold on. Do I divide it? Let me divide that. Get my calculator here real quick. Yeah, I'm assuming that's 6, but let me just double check. Yeah, it's 6. Okay, so divide this by both sides by 23. X is -6. Okay, so now let's plug it in. 2 times -6. -12 minus 7y is 2. Okay, so my point here is -6, -2, and that's a solution to this system. I could double check by plugging it into both, but this method is going to work for us, and we got it. All right, so here on this one, I warned you this was coming. If you look here, there's no simple way to make this disappear with an addition. So what we could do is sometimes we have to multiply both equations. Now, you'd quickly see I can multiply by, if I switch 5 and 2, just I can multiply the top by 5 and the bottom by -2. That would always work. So you can always just multiply each of them by the other coefficient. Just make sure that you make one of them negative so that they'll disappear when they multiply through. Or we could just have easily have multiplied the bottom by 3 and the top by 10. That would have made opposites. So we just need to create opposites. So here what we're going to do, they're running a -5 through the top, so we can create an opposite, and a 2 through the bottom. And because of the nature of the 2 and the 5, that'll work. So after they've run them through, we create this. Now the x's are opposites here. So I've got -35y equals 140, y is -4. Plug that back in, get x is -2. So we have it. Now, substitution would always work. Any of the approaches would work. You could graph it if you wanted. You could do substitution. But elimination tends to be an easier method, but students will also choose substitution a lot too. Typically on a test, I would ask you to do one by each different method to show that you know them all. Okay, let's do addition, elimination again, but we've got fractions here. What I would do first of all, and I hope they did this too, I would first clear the fractions out of the problem. Do you remember how to do this? So this may not get us something that will instantly drop out, but what it'll do is it'll make this much easier to work with. So I'm going to multiply through everything here by the least common denominator, which would be 6. If I multiply every term in this by 6, do you remember what will happen? And then here I'm going to multiply every term through by a 4. If I do that, if I multiply everything through by 6, I'm going to get this equation where the fractions have dropped out. We clear the denominators. It's a pretty common trick all the way back to even pre-algebra. So run a 4 through here, or I guess maybe algebra 1. So by running an LCD through both of these, I've now cleared them out. And it turns out that the equations I have, well, let me show you. The equations I have an opposite here, like the y's could drop out if I just add them, but that's not always the case. And if it's not the case, clear the fractions and then just do the same trick we did before. There's nothing that says you couldn't repeatedly alter the equations. So here I've got 4x equals 22 now. Yeah, so I solved it the more difficult way, but 11 over 2 is 5.5. They plugged that into the other equation and got 7. Okay, so pause this if you want to try this on your own. I'm going to create something where there's the opposites. I don't have it here. Let's run a -3 through the top and a 2 through the bottom. I'm just taking those leading coefficients and flipping them to the other equation, making sure one of them's a negative. So what I'm going to get here is -6x minus 9y. Okay, that'll do it. So now I've got an ability to drop the x's out of here. Add those up, I get y equals -4. Okay, if I know y, I can plug it into the other one, either equation, to solve. And there I go, 10, 4. Okay, I think I sliced this wrong. I think the next video is going to show you the other trick that can happen, the problem that can happen. So we've talked about sometimes the equations don't touch each other at all. And if that's the case, when we try this addition method or the substitution method, something is going to go wrong. Now, I think this is set up for substitution because I know what x is. So let's see if that's what they did. Yeah, they did. So if I know x is this, let's try just subbing it in. And if we come up with a value of x here, or y, then we know that if I put the one line into the other line, then the place where they hit each other is going to be revealed. But look what happens. When I sub that in, I get left with something that all the y's drop out. You see I create a -2y and a +2y, and all I'm left with is numbers. I'm left with 9 equals 13. Now I'm sure you are familiar with this trick if you took Algebra 1, but so 9 equals 13 is not telling the truth. So this means there's no solution, that this system does not intersect. And if you wanted to see, you could see that actually if you solve this for y, well, let's just do it like this. So if you flip this back to the other side, you see we have x plus 2y equals 9 on the top and x plus 2y equals 13 on the bottom. If you put these in slope-intercept form, they're going to have the same slope but different intercepts. So these are parallel lines. So the reason they don't hit is they're parallel, but what you'll see when you try to solve it is you get a lie. That is not telling the truth. So there's no solution. That's not true, so they must never touch. Okay, so we could solve this by any approach that you wanted, but if you graph this, can you instantly see this portion is the same? So if you put this in slope-intercept form, what you're going to find is these are parallel lines with different y-intercepts, so they are not going to touch. But let's do it here. So let's run a negative through this one in order to create opposites. Okay, so if I run a -1 through there, here's what I create. Well, if I try to add these now, I'm going to get 0 equals -4, which is not true, so I get no solution. Okay, so we took a look at the substitution method and the addition method. They'll both work. We're trying to connect the lines, put them together. And if they can be put together, what we're going to come up with is their point, where they're both telling the truth at the same time. We're going to find their intersection point, the solution to the system. So at the end there, we saw that it's sometimes possible they don't touch at all, And what you'll get is all the variables will drop out and you'll be left with something that's telling a lie. Now we'll continue that idea in the next video.